So till now we have seen how to move the data from internal memory to the registers or the register to the RAM locations, and how to move the data from external memories to the registers or memory locations with the help of a MOV mnemonic. So that is the first type of mnemonic which is used to move the data from source to destination. Now we will see the second mnemonic, push or pop. PUSH, push or pop. You know very well these operations are used with the stack memory. So what is the stack memory? That is also part of the RAM. So from which location you want to use as a stack memory, you can decide with the help of SP. So how to define the stack memory, from which location you want to define the stack memory for your application, you can use move instruction. Now I will show how to use the stack memory or how to define the stack memory, from which location you want to use RAM as a stack memory. So with the help of move instruction we can define the stack memory. So MOV move SP stack pointer, and from which location you want to use stack memory, nothing but as. So that is a memory location address you have to specify. Example, I am going to use 12H. From 12H location I want to use as a stack memory. So you have to use this instruction, move space SP comma as 12H. So 12th location onwards your memory is going to utilize as a stack memory. So like this you can define the stack memory with the help of SP register, stack pointer register. Example, I am not defining any SP, I am not executing any instruction to define the stack memory. Means default memory location of the stack memory is 07H. So if you are not defined SP, means default SP value is 07H. So default SP value is 07H. Remember this. So what is the use of stack memory? Generally it is used to store the temporary variable values, or it is used to store the return addresses of a function. When you are using functions, you can store return addresses. So what are the operations are there to work with the stack memory? Here 8051 is having two mnemonics, push and pop. So push operation is used to store the data onto the stack memory. Pop operation is used to get the data from the stack memory. So just observe these two instructions, push space ADD. Here small add means address. So you have to specify some address location after push mnemonic. So example, I have written push space 10H, means you are pushing the data into the 10H location using push operation. Pop address, ADD means address. After specifying the pop opcode, you have to give some address. So you are getting the data from the stack memory, you are loading that data into this address location. So these are the two mnemonics are there with the 8051 to work with the stack memory. Push space address, pop space address. So look at this diagram. Here SP must be specified. If you are not specifying, it is locating at 07H. So whenever you are using push operation, definitely SP will increase by 1. So if you are not specifying, is 07 will be there at SP. Now it will become 8. SP plus 1 means 08 location it is pointing, and you are pushing some X value, 8-bit data value, into the 8th location. Then again you want to use one more push operation, SP will become SP plus 2, nothing but 9 it will become. So 9th location Y value is stored. Like that, how many pushes you want you can do. After some time you want to pop some operation, means you know very well stack memory is top of the stack will get. So SP is pointing top of the stack, you will get the top data. Then the data must be moved into some location. That location address is specified by this address. So pop some address. So you are popping the data from the stack memory and you are loading that data to this specified address. So like that, after doing one pop operation, you have to decrement the SP by 1. So then you will get the next top of the stack. Then you can get the next item and it can move into this specified address. So this is about stack memory and push and pop operations to move the data from stack memory to specified address or specified address to stack memory. So just see here, I am moving 10H into the SP. So SP nothing but direct address of SP is 81H. You can use direct addressing mode instruction, or you can use register addressing mode instruction to specify the SP. Here 10th location onwards my stack memory will start. So I am moving 90H to R0, 74H to R1. Now push 00H. 00H means memory address. From this address you are getting the data and you are moving into the stack memory. Like that you are doing two operations, push operation. Next I am doing pop operation. I am going to get the data from the stack memory and I am storing the data into the 00H memory location. So here 00H address is R0 address. Okay, like this you can use push and pop operation to work with the stack memory. And third mnemonic to move the data from source to destination is XCH. This is the third mnemonic which is used to move the data. And see this, these are the combination. You have to use these combinations only when you are writing assembly language program. So XCH, nothing but exchange the data between the source and destination. Here R, capital R with small r means R0 to R7. You can take any register of any particular bank, and that registered data is moved into the accumulator, and accumulated data is moved into that particular register. So exchanging source to destination and destination source. So these are the two operands are going to exchange data between them. So here you can use address also. This is a register addressing mode of that instruction, and next instruction is direct addressing mode. So here a small ADD means you are going to give an address. With that that address will have some data, accumulated data, and that memory location address data is going to exchange. Next one, third one is indirect addressing mode. Here you can utilize indirect addressing mode also to exchange the data between two operands. Next is the XCHD. This is the special mnemonic. It is used to exchange the lower nibble of the two operands. So every byte is having two nibbles. Nibble nothing but 4-bit binary data. So 8-bit data is divided into two parts, two nibbles. So lower nibbles of the operands are going to exchange. So these are the example. So R7 register is having some data, accumulator also having some data. They are going to exchange data between these two operands. Here in this second example, I am using direct addressing mode. So F0H is a address, memory location address, and it is having some data and it is exchanged with the accumulated data. Then third one, it is example for indirect addressing mode. And fourth one, @R1, nothing but R1 is having some data. That data you are treating as address, and that address is having some data. That data is exchanged with the accumulated data, and that is only lower nibbles, not totally 8-bit data. So this is about moving data from source to destination with the different types. First one is MOV. MOV is used only internal data exchange. Then MOVC for external ROM or internal ROM to the memory locations are registered. Next MOVX is used for external RAM, and push and pop is used for stack memory operation. Then XCH is used to exchange the data between the two operands, and XCHD is used to exchange the lower nibble between the two operands. So this is about moving data.